Hello, and welcome to another episode of Amiga Retro. And as promised, I'm going to do a review of the Dicke Olga Amiga 2000 68030 accelerator card with 128 megabytes of RAM. As you can see, you can also get the 64 megabyte version. Now these are built, this is all open source, so these are built by certain individuals. DJ Cook was the one I purchased it from MB. I will give a link to that in the forums if you are interested. He's making some now, but because it is intensive labor to solder all these parts on, there'll be batches, just like everything else, right? So you miss this one, you might be lucky on the next boat, if you know what I mean. Okay, so let's go over some features of this card. So of course, it'll take the 68030 or the 68EC030, which is of course the version of the 68030 without the MMU. I definitely would suggest using one that does. You get much more usability and features sets out of the full-blown version, and there's not much difference price-wise when you order these. And you can order the one from when I got this card. It was actually that I replaced this one with a rated 50 megahertz version. The one it came with was rated at 40. It still can be overclocked to 50 and maybe even 60, but I felt a bit more comfortable putting a rated 68050, 68030 at 50 megahertz versus the 40, because I am going to overclock this to 60 megahertz. And I also took the liberty of installing the 68882 into that socket, and that's a PLCC chip type. So if you go that option, they're also available on eBay for a pretty cheap price. And unfortunately, a quick side story, the ones I ordered, I don't think they were counterfeit, but they were just as bad. They were defective. It worked until I tried to do some kind of FPU operations like an AIBB, and it crashed the machine. So I ordered some new ones, and this one, I'm happy to report, works. So that's not going to foul up this presentation, hopefully, besides me, at all. So there we go. So 68030 or the 68EC030 stock at 50, or you can go up to 60 megahertz. You can even go lower if you want as well. Apparently from 30, 30 to 60 technically, if everything goes well. It does have a fallback mode, which you can use these switches for, so it can go back to the 68030. Oh, really? It can go back to the stock 68,000. So if you're having software compatibility issues, you will have that option. The good thing though is, even though you will disable, the CPU and fall back to the much slower 68,000 processor, you will keep 4 megabytes of RAM here, 4 megabytes of that, and you will still have IDE, compact flash compatibility, and boot as well. So you still have a bootable system off of a compact flash or hard drive or whatever option you go. So it's not like you're just going to have to go back to floppies if you go to the fallback mode. You can overclock it up to 60 megahertz, which I mentioned before, and I think you can go from 30, like I mentioned before, sorry, from 30 to 60 megahertz. There you go. You can have 64 or 128 megabytes of RAM. I believe the 128 megabyte version is much easier to find out there in the wild. It also supports the MapROM function, and the MapROM tool version 1.11, which you can download, will enable all the features that you can use along with the OS. But it's mainly used to turn off and on IDE wait states to make the IDE, like the SATA interface here, or the compact flash card, or just the IDE in general, faster. And if you're having issues with corruption or whatever, you can increase the wait states to make it more compatible. And of course it has the boot ROM, which is actually located right here. And that is either for the Octagon, which I believe they had some issues with. So this one's actually the LIDE version right here. I think this one might have both in it. Don't quote me on that, but I'm using the LIDE driver for the compact flash and my CD-ROM. So there we go. And it has the 40-pin IDE interface here, and it has a 44-pin IDE interface on the back, which I'll show you. Show you shortly. That's a tongue twister. Which is, these are the pins here, right here. And like I said, I'll show you on the other side. It gives you, well, I'm also flip it over to this side and keep you in frame. it also gives you, yeah, there we go. There's the 44 pin IDE header, so you can put like a laptop hard drive on here or anything else that is 44 pin. And you can also use a SATA M2 if you want, but it also has clock ports. There's 2 of them, and one of them is basically a clock port you can use that's A1200 standard. So technically you could use like anything I would use, like a battery backed up clock if for some reason the one on your Amiga 2000 is defective, or you can use it for other compatible clock port devices that were made for the A1200. And then you also have another clock port as well, which can be used for other devices, which is covered in the manual. And yeah, and you also get, turn over here again. I should have done this when we were on this side. There's 2 5-volt headers here, one here and one here. So this ideally you probably use for a fan if you want to cool this, and this actually doesn't run very hot, even at 60 megahertz. And then you have another 5-volt available header here for other fans or whatever you want to use. And there's also an auxiliary, 5-volt input here. I've actually used this to flash. There was an update for, yes, this one here, the Xilinx. There was an update for that, taking me to firmware version 0.008. And you need the board powered. So instead of the clumsiness of trying to do that, hooking it up to the PC to program it and then having the card like installed in the 2000, I simply powered it here from a separate power supply. Worked like a charm, gave it the voltage it need. I used the available header here for the Xilinx, and I programmed it. And there you go. So instead of pointing at things like I've been doing, I will now point with a purpose. So I'm going to go through the headers and all the fun stuff that they do. Okay, and now we shall go over all the jumpers and the headers and all that fun stuff. And all this will be in the manual if you ever purchase this. The manual is obviously available on the forum to download to give you all the specifics right here. So here we go. So these 2 here, this is for the clock port, which I showed you on the bottom of the card. So it's enabled or disabled. So right now they're in the enabled mode. And over here we have the 5-volt header for various fans and whatnot. And then the other one we have here is the fuse test. And this is left in the on position. And what the fuse is, which is really nice, except for this input here, there's 750 750 milliamp fuses that are resettable. So they'll self-reset if there's an overcurrent, so you don't have to worry about burning out any traces or components. With this on, all the fuse LEDs will be lit. If you take this off, they will be dark. And I actually prefer to leave it off unless something's going, something's not working. I can quickly throw the jumper on to see if any of the fuses have been tripped. The reason why is if you leave this on, there'll be LEDs, and you'll see that later. It lights up like a Christmas tree, so there's going to be a lot of LED activity going on here. They stay on constantly as well, by the way, and I guess it makes no difference if you have the cover closed, but it's just kind of funny, but you'll see. Okay, and then we will have the, what do we have here? We have the MMU and the, one second here, cache. So that's enabled or disabled. Of course, as you can see, there's nothing on there. So you want the MMU and you want the cache enabled, but for some reason, if you want to disable them, you can put jumpers on there as well. And this is the BSW, which is a German name of some sorts, for the revision A of the Amiga 2000. So most Amiga 2000s are the Amiga 2000B. Apparently the A version, you need to have this enabled. So you have to have a pin here to have accelerator card, and you have to, unlike this one, which has this, you can leave the 68,000 in, you have to remove it for the early German versions of the Amiga 2000A. So you'd have to put a jumper on here and take the 68,000 out of the slot. Of course, when you do that, you're going to lose the disable functionality of the CPU. So you can basically the CPU disable the fallback mode. You won't be able to use it on the revision A of the Amiga 2000. The Amiga 2000A models. Yes, that went well. Okay, let's continue. And here we have a set of jumpers, JP2. This is actually and JP3. I think that might be, yeah, this is JP3, JP2. Anyways, these two here control the clock frequency for the CPU, and I have it set up right now. There's no pins on here at all, like no jumpers. And I have these ones set between pin 1 and 2, and this basically overclocks this to 60 megahertz. So the system is running at 60, and it runs actually just fine. Okay, and then we go down the list here. We have the IDE activity lights. You have 5 volt and 3.3 volt indicators. So these should all be lit up. We'll find out when I get it in. I'm not sure if this is off, if there's nothing plugged in here, but there's a compact flash LED that turns on when it's inserted. But this just means there's power, I believe, for all these devices. Power for the IDE device, you have your 5 volt switch, and your 3.3. Okay, and then you have your CPU switch and your auto boot. So that is basically these switches here, but you can actually jumper them and they would just bypass this, so you would be just disabling the 68030 and everything would be, and the auto boot, so you basically would be putting it back to a stock Amiga 2000, but these switches do the same thing, so I would just leave these off. And then you have the SATA off, so there is a SATA port here, and there is actually one on the back for an M.2. You only can use one or the other. You either use this or use the M.2 on the back. I'll be using this. So but you have to leave it enabled. If you don't have any intention of using these two ports, this port here or the one in the back for the M.2 SATA, or the M SATA, you just have to not worry about such things. You can just turn it off. And next, we have the CPU clock divided by 2, and it's self-explanatory. So right now it's at 60 megahertz. If I put a jumper here, that would divide it by 2, it would be running at 30. So you would be underclocking the CPU. Okay. And then we have here is the 40-pin IDE header. And then you have some more jumpers over here, which is your key power. So you have a disc-on module, or if you have a compact flash card you don't want to wire like an external power source to, it can get powered through this interface right here. Be careful, some devices might cause issues, so just take that with a grain of salt. But to be on the safe side, I would just power it from the power supply, or like this one uses like a floppy type connector. I do have ones that the compact flash cards that plug in here, that you can just use like a floppy type connector to power it, but it's up to you. Just be careful, because there may be issues depending on the device you're using. So I would just try to go with external power. So that to me is turned off. And you'll have the cable select, which is similar for IDE drive. So master, you'll figure out by the cabling, is it master or slave, depending on the position of the device on the cable, etc., etc., etc. And then you have the CF config jumper, which is going to put it in master slave mode. So I'm not sure. That basically is like compact flash. You can have one compact flash being like the master, and then a CD-ROM or another compact flash being the being the slave. But the thing is, your mileage will vary on that. It all depends. You have to basically trial and error. I could never get my CD-ROM with the adapters. It's a SATA CD-ROM, but I had an IDE to, SATA adapter. It could not work with anything, even on the one in the back, here or here, but I did get it to work with the SATA. So I actually have the compact flash as the primary, and then there is a jumper here, that one. You can set the SATA to either primary or slave. So I have set for slave for my CD-ROM, which connects here, and then we have the, compact flash card in there. And that's pretty much it. I hopefully didn't bore you to death on that part, but that's pretty much it here. And one thing too is, if you want to run right now, this is a 40 megahertz 6882. It's running at 60, the same clock frequency, and it runs fine. It doesn't get too hot, and it seems to be stable, even though it's slightly overclocked. But if you want to run at a different frequency, you can put a clock in here and then set this jumper accordingly. So if you want this to run a different frequency, let's say put a 40 megahertz crystal in here, and then you can just move this jumper over. So this will run at 60, that will run at the crystal frequency, which in this case would be 40 if I put one in there. And that's it, I guess. What we'll do now is turn it over, I guess. Oh, I have to do that because I forgot to mention. On the back here, besides the clock port headers, yeah, there's an IDE, basically your hard drive activity LED. So in the case of the Amiga 2000, I can hook it up here and it'll show all the activity that's coming on the card for any of the LIDE or ID interface or whatever, right? And as you can see here, you got space if you want to put an actual drive. And this is a space for the Delfino card if you want to hook it up to a clock port, which I don't have one of those anyways, but that's a 16-bit audio card of sorts, which I know almost nothing about because I've never owned one. But that, as they say, is that. So there you go. So I'm going to get all this stuff out of the way, and I'll show you how easy it is to install it into the machine. I shall return. Okay, excuse me, I have returned. The 68000 is, you can't see it, it's installed. So I do have the ability to go to fallback mode. If it's not in there, it's not going to do anything. And some people may not need that, so it's up to you if you want to leave that installed or not. I think it will boot without it, but I have not tried, so do not take my word on it. So here, well, it's pretty easy. The card, I already removed the CPU blanking plate and carefully put this in here, and there's a lot of room to make it fit. Okay, it looks like it's in there. So I'll just push gently. I said gently. It's lined up. So there we go. Yeah, you gotta make sure it's lined up. It doesn't fit in. It's kind of loose, so make sure the slot's lined up, and then just push. And there it is. It's in. So that was relatively simple. As you can move you around to this side, there it is down in there. I'll zoom in a bit for you. And as you can see, it's like usual, pretty tight fit against the power cable there. But it gives you access to everything. And I do have the SATA CD-ROM cable here. Let me zoom out a bit. And yeah, that will actually plug into the SATA port there. And that's the only way I could actually get this SATA CD-ROM to work. Because before I had a SATA to IDE adapter, and it did not work no matter how I tried to configure the IDE ports on that. But it kind of makes sense. It's a SATA drive anyways. Now I don't even need an adapter, and it works just fine. So that's actually ideal. Just wish I tried it sooner before the video. So what I'll do now is I'll connect this up to here and get it powered on, and I will join you at that time. Just a quick note before we go to the frame grabber. It's easier to actually plug this cable in because it's so close to the power supply when the card's out. So I just had to pull the card out, kind of, pull it out completely, plug that in, and then of course put it back in on the angle down, and it's no problem. So it's just easier than me trying to stuff my hand in there and whatnot, or remove the power supply and all that fun stuff. Okay, so we're going to turn this on like I promised before and see what happens. Yes. Okay, as you can see, and maybe hear, the Amiga 2000 is on. All these green lights are the fuse lights, and as you can see, it can get quite busy in here. And you can also see that I don't know if you can see it from there or not. One moment. Why am I doing this? Must give you more information. Don't know how well that's going to pick that up. And it doesn't. But the IDE light here does flicker whenever it's trying to access the drive. And right now there's no drive hooked up, no compact flash at all. So, but what I was mentioning before is all these green LEDs can become quite distracting, but I guess not so much when the case is closed. But if you do remove this jumper here, which I have loosened, it shuts them off. And now it's just the the voltage lights, the compact flash, IDE, all that stuff. So I'll just leave that on for now. But you can, that's all that does is just turns off the status. The fuses will still function. It's just you wouldn't know without putting that jumper back on if one of them had been tripped or not. If you're having issues, part of your troubleshooting. You know what I mean? Yes. So anyway, we'll go to the capture device and go from there. So as you can see, computer is ready to boot off of something. This is a good place to start. This is at least showing that the computer will boot with the card in the slot, and hopefully that means that the card is functioning properly. So all they need to do is go to the back and install a compact flash card and make sure that the toggle switches are in the correct position. And the compact flash card, it has a pre-installed version of Workbench 3.2. So this should be quick and painless. I hope everything should work just fine. I tested it previously, so hopefully the camera does not make a fool out of me. So here we go. Going to restart the computer once we get the compact flash installed. So pardon me for the shaky cam, but I now have the compact flash card installed on the compact flash card slot, of course on the back, and the switches are to the left, which is in the positions you want them in. The 68,000 fallback mode is off and auto boot is on. So now we will return to our regularly scheduled programming. Yes. So we are ready to go. Compact flash installed. Workbench 3.2.1. Toggle switches in the correct position. I will now power on the Amiga 2000 in 3, 2, 1. And it is on. The hard drive activity light on the front of the Amiga 2000 is flickering, and yes, it's starting to boot. It takes about 30 seconds or so. And then once we get to the workbench, we will do some quick tests to confirm the proper operation of this accelerator board of the gods. At least pretty damn close. Yes. So here we go. So I've already taken the liberty of editing the workbench title to what is actually in this machine, but you cannot just take my word for it. Let's prove to to everyone that that is actually what's in this. So one of the first tools we're going to use is show config, that comes with 3.2 as in workbench, and it's a very nice tool, much improved from the older versions, which was basically just CLI based. And this gives you much more information, but as you can see, we do have a 68030, we do have a 6882, and the MMU is present. And there's your 2 megabytes of chip and 128 megabytes of fast. So there we go. So let's go over to sysinfo and see what she has to say. As you can see, it's agreeing with show config, and we will go to the speed button. Now let's see how fast this is. Remember, I'm running at 60 megahertz. 10 megahertz bump over 50. And there we go. We've got roughly 13 MIPS and 1.73 mFlops. I'm not exactly sure about the mFlops. I think they're about 1.4 for a 50 megahertz version of that, of the 6882. But I know for sure that you get between 8 and 10. Usually you're averaging around 9 MIPS, maybe 9.5 for the 6830 running at 50 megahertz. So we're definitely overclocked, and we're getting a nice speed boost. So let's go to the drives and see how fast our compact flash card is. So I'll just pick DH0, and it shows that it is indeed using the LIDE device. That's the in that boot ROM that I showed you earlier on the card. And let's see how fast this is. Not bad, 5.6, 5.7 megabytes per second. In comparison, this same computer here with the Buddha IDE interface gets around 3.5, about 3.5. So this is about 2 megabytes per second faster. So not too bad at all. But we can actually tweak the speed a bit. So let me exit this and quit. There's a MapROM tool that you can use, and I will show you right now, that you can use to change some settings. So let's go to the Amiga shell, and this you can download from, there's a link in the forum, or you can download from GitHub. So I'm going to type in MapROM status. This will show us our current configuration. So this is the MapROM version itself, and it's pretty recent. The firmware version, I believe I was at before I flashed it, and that could pretty much be a video in itself because it was rather interesting, but I got it accomplished. I think it was at either 006 or 007, and it's been upgraded. The fuse map, I'm not exactly sure what that is exactly, so I'm not going to even try to explain that. I'm just going to leave that alone. The VBR by default in chip memory. You can put it in the fast, and you can do that with this utility, but I've really noticed no difference in speed improvements if it's enabled in FastRAM, and most of the times it causes compatibility issues. So I would suggest leave it alone, leave it in chip RAM by default. But this is the one of interest. IDE wait states. So this might be CPU cycles or a certain timer that it uses before it reads and writes to the compact flash. So right now it's set to 8, and that's its default. And it will, like I said, it was around, what, 5.6 megabytes per second. So let's change this to 1 and see what the speed difference is. So if you want to know the command structure, just the usual question mark at the end of MapROM here. And as you can see, wait state. And there you have the fuse option, kick file. I'm not sure what it is. Diag file, kick ROM. There's your VBR to fast, remove, status, quiet. And there's very limited documentation on this. It does exist, but the only ones I'm interested really in, that you, or even that you would use, would be the wait state, maybe the kick file, like to load a different version of Kickstart into its memory, so you can, have different, OSs at your disposal, and VBR to fast, pretty much, and status, of course, which we just used. So let's do the wait state. We're going to change this to 1. And it's not case sensitive, don't worry about it. This is not Linux, you're fine. And if I could spell, and space is fine. I think equal, it accepts it, but it doesn't matter. We're going to change it to 1. Now, it doesn't really give a lot of output, so just to double check it actually took, we're going to go back to status again, get my mouse pointer out of the way. And indeed, it is set to 1. So let's go back to sysinfo and drives, NTH0. Remember, we were about 5.6, 5.7 last time. Let's see what difference this makes. Look at that. We gained 3.2 almost megabytes per second. Now, the dangers of this, depending on the compact flash card you have, if it can't keep up with the speed, which hopefully it should, yeah, you should be able to, what I'm saying is you might get errors. So if it can't handle the speed, you might get read errors, write errors. It might start corrupting data on the drive, so always make sure you have a backup of this before you go down that route. But this only happens in the command line. So once I reboot, it's going to default back to an IDE wait state of 8. So it's a kind of like a safeguard there, right, just in case. But yeah, not too bad at all. And so that's so it's good about this MapROM tool that they updated. It now controls all the features that the Dicke Olga card has to offer. So what we're also going to do, make sure our the thing like a CPU, the FPU, is working properly. This is what I mentioned before, or I may or may not have, because I did several retakes while making this video. When I originally put the 68882 that I bought off of eBay, and I don't think it was counterfeit, but it was defective. So whenever I went to run, which I'm about to soon, the beach ball test, it would do a couple of lines, get some garbage, and then the system would crash. So I happen to have an extra one kicking around from a different project I was working on, and it works fine. This is the FPU right now. Remember, they're the PLCC type. So let us do the quick test. So everything's enabled, the 68020 math and the coprocessor math. This is the most important one. This is the one that's going to use the FPU. Okay, and here we go. And 5.85 seconds. So what we're going to do now is we're going to disable the coprocessor math and see how long it takes. So we are roughly about, let's say just 6 seconds. And let's see how long this takes without the math coprocessor. This may go on for a few seconds, so I'm going to pause this and come right back. Yes. And we have returned. The results will be known shortly. This test is almost done. Almost. And there we have it. 46.58 seconds. So about 40 seconds, roughly, longer than the coprocessor being enabled. Another test we can run too is a memory test to see how fast the memory is on this card. And it is. It's 20.31 megabytes per second. Not too shabby at all. In comparison to a stock Amiga 3000 at 25 megahertz, it's 2.58 times faster. Now we are running at 60 megahertz, so just over 2 times faster than, the lowly A3000. But still, it's probably just a bit faster, even if they're at the same clock speed. So not too shabby. So I I'll close out of this. Now another feature that's kind of nice that comes with Workbench 3.2 is the mounter. Now this by default is going to be set to the SCSI device. Remember, we're using the LIDE device, and this will be for anything like Buddha or whatever card you have. Just change this line here to the device you want. Because if this was SCSI.device, it won't show anything at all. So if I actually put SCSI in here, and make sure I don't misspell it, save, and then I run this, no device present, because it's the wrong interface. So let me put that back to LIDE, and this will go for anything, right? If it's Buddha, SCSI, or whatever, or any of the Phase 5 stuff. So we're going to go back to LIDE device, and make sure it's not misspelled, and then run it. And there, it shows all your devices, and that's interesting. My CD-ROM used to be device 1, and now it's nowhere to be seen. Like 7 places it could be, and it's neither of them. I'll have to figure out what that's about. Yes, so let me try to figure out what's going on with that, and I will be right back. Well, I'm not sure what actually happened there. It's my CD-ROM has disappeared. But anyways, in a perfect world, you would see the CD-ROM here somewhere, device 1, whatever, 2, and then you know that's the device number to assign to the CD-ROM driver, right? Usually stored in storage or something to that effect. And it's kind of nice too if the compact flash card's listed, and it's a 7.5 gig. It's actually 8, but that's what it reported as. And if you double click on it, you actually see all the partitions. So it's a nice tool to have, and it's also good, like I said, the CD-ROM, when it shows up, it would show up in this list, and you know what device number it is. So what we're going to do now is we're going to demonstrate the leaving auto boot on, the fallback mode. So it's going to use the 68000 processor on the motherboard. So what I have to do is shut the computer off, hit the toggle switch, and then boot. So I'm not going to bore you with that process, but I'll shut the computer off, and I'll be back to you when it's in 68000 mode. So it's been booting for about 30 seconds so far in 68000 mode, so I'm still waiting for the workbench to appear. Eventually. And there we go. And as you can see, it's taking a while to load all the stuff that's in the workbench startup, and it's going to take a while to load the workbench backdrop image as well. And my clock hasn't come up yet. It will eventually. Remember, we're only running at 7 megahertz at the moment, but we do have our RAM. Now, remember, it's 4 megabytes, but there's stuff running right now too as well. And this is OS 3.2, which uses about an extra 512K of memory for other stuff. So yeah, if this was 3.1 ROM and 3.1 Workbench, it would be a bit more responsive than this. It's just as OSs improve, system requirements, of course, become a bit more taxing. But except for games, there's really no reason to use a stock 68K machine, but I digress, I guess. And as you can see, the interface is not the quickest, the GUI that is, to respond. But let's double check our show config. And it should confirm we're only running the 68000 with absolutely nothing else. And it's taking a while to load. One moment, please. And there it is, eventually. And as you can see, you got the 68000 and nothing else. No FPU, no MMU, etc., etc. And yeah, that much we knew. So what we're going to do now is go into sysinfo and do a speed test. And as you can see, it's reporting correctly so far. And once again, we wait. 0.74 MIPS, and of course no mFlop since there's no FPU. And as you can see, it is performing just fine for being a stock 2000. And let's go to the drive section. Let's see what our speed is now. It's not going to be anything amazing either for disk access, but we will find out. And survey says 1 megabytes, barely. So just over 1 megabyte per second. Yeah, that is pretty much that. We can go into more confirmation, which Amiga will work. And as you can see, yep, 7.1 megahertz and pretty much nothing. But it does show the card, does show the memory address space and all that fun stuff. So yeah, there we go. So why would you use this mode? Because you might have some demos that don't run properly. Sometimes even with WHD load, it has issues with certain titles, cache related issues, all that fun stuff. You could be older games. In that situation, you could actually turn off the auto boot feature, and then you can just boot directly off a floppy, and it won't even be aware there's a hard drive, right? So it pretty much turns off the card for the most part. So yeah, it's fun stuff, isn't it? So I'm gonna go back to the this version of the card, and I will join you at that time. Okay, 68,000 mode is now disabled. Now we're going to go back to the full 68030 goodness. Just to let you know, if you're going to use the 68,000 fallback, do that when the computer is off. If you try to flip that when it's on, it's just going to lock the computer up. I don't think it's going to hurt anything, but just even with the auto boot, best idea, just have the computer shut off completely and toggle the switches, and then away you go. So yeah, there we go. We're back to the much better version of the cards and unleashing its full potential. So that pretty much brings us to the end of this video. I pretty much got everything I accomplished. Once again, I kind of got close to the wire for when I have to leave again for work. I know I always say this, but I just I wish I had more time, because I want to polish my videos up a bit and spend a bit more time, especially in post-production, and that also takes a bit as well. It's just me. I don't have an editor or anything or anybody that does that stuff, so it's just me, myself, and I, unfortunately. But one thing I also forgot to mention is this is actually the 50th. Sorry, I can't say that right. The 50th episode on Amiga Retro, and actually back when it started as it was Amiga Retro Adventures, if I could say that properly. So kind of cool. Now, mind you, that was over 5+ years, but still better than nothing. So I do have a couple more videos planned. Hopefully I can get a couple out during the summer. It all depends on how things go. But I do want to thank my subscribers too. I'm at 1,800, slightly over that. I appreciate every single one of you. And if you're not a subscriber, well, what do you know? Why don't you subscribe? And also hit that like button, subscriber or not, because that's also appreciated. So that wraps up this video. Any questions, any comments, feel free to leave them in this in the video itself. And whatever you call that space underneath the comments, I guess. It's getting late, sorry. Yeah. So that's about it. And as always, thanks for watching.